Green's theorem is a rule that connects two different ways of measuring the same thing. It tells us that a line integral going all the way around a closed curve equals a double integral spread over the flat region that curve encloses. Let's state the formula in plain words first. The closed loop integral around the curve C of the quantity P dx plus Q dy is equal to the double integral over the region R of the quantity curly dq by curly dx minus curly dp by curly dy dA. Now let's write that same idea in symbols. Closed loop integral over C of P dx plus Q dy equals double integral over R of open bracket curly dq by curly dx minus curly dp by curly dy close bracket dA. Let's set up a worked example so we can see this rule in action. Our vector field has two parts, p equals x times y and q equals x squared. Our region R is the unit square with corners at the points 0, 0, 1, 0, 1, 1, and 0, 1. Here is the two-dimensional view of that square, sitting flat in the xy plane. Now watch it lift into a three-dimensional view, the same square held flat at height 0, so we can see it as a flat sheet inside xyz space. We will go around the boundary of this square counterclockwise one side at a time and add up the line integral on each side. First side, from the point 0, 0 to the point 1, 0. Along this side, y stays at 0 and dy is 0. So the whole expression p dx plus q dy collapses down to 0 dx. This side contributes 0 to the total. Second side, from the point 1, 0 to the point 1, 1. Along this side, x stays at 1 and dx is 0, so the expression becomes 1 times dy. Integrating dy from 0 to 1 gives us 1. Third side, from the point 1, 1 to the point 0, 1. Along this side, y stays at 1 and dy is 0, so the expression becomes x times dx. Integrating x dx from x equals 1 down to x equals 0 gives us negative 1/2. Fourth side, from the point 0, 1 back to the point 0, 0. Along this side, x stays at 0 and dx is 0, so the whole expression collapses to 0. This side also contributes 0. Now we add up all four sides to get the total line integral. 0 plus 1 plus negative 1/2 plus 0 gives us 1/2. Next, let's compute the equivalent double integral over the region. We need the derivative of q with respect to x, which is curly dq by curly dx, equal to 2x. We also need the derivative of p with respect to y, which is curly dp by curly dy, equal to x. Subtracting these gives us curly dq by curly dx minus curly dp by curly dy equals 2x minus x, which simplifies to just x. Now we integrate x over the unit square. Integrating x with respect to x from 0 to 1 gives us 1/2, and integrating with respect to y from 0 to 1 gives us 1, so the double integral equals 1/2 times 1, which is 1/2. Check step. Let's confirm both methods agree. The line integral around the boundary gave us 1/2. The double integral over the region also gave us 1/2. Both values match exactly, which confirms Green's theorem works correctly for this example.